Good day, viewers. This will be another edition on triangles. Especially, we will be concentrating, or this presentation will be on inequalities in triangles. So that will be inequalities in triangles, inequalities in triangles. Okay, now first of all, what we mean by inequality in triangles? We know we have three types of triangles. First of all is equilateral, then we have isosceles, isosceles, and we have scalene, scalene. This is a three type of triangles. We will not find any inequalities in equilateral triangles. There will be no inequalities because these are all sides are same. All sides are equal. They are not only same, all angles are equal. So you will not find any inequalities in equilateral triangles. Isosceles triangle, yes, there will be some inequalities because only two sides and two angles are equal. And the third sides, if these two sides are equal, then the third side will not be equal. Because if the third sides become equal, then it will become an equilateral triangle. It is a scalene triangle. That means all the sides and angles are different. You will find inequalities because all the sides will be different, angles will be different. Okay, so basically that would be our concept of talking about inequalities. Let's see what advantage or what things we get out of inequalities. First of all, we can say it is the first theorem, and that theorem I will follow again as usual. I will follow the book, and in this book I will also quote the same theorem. This says inequalities in triangle. That is section 7.6. So we will start the section 7.6 on this issue. And the first one that will be first inequality or the first theorem, that is theorem 7.6. Itself is 7.6. That's good. It matches up. This thing, if two sides of a triangle are unequal and unequal, the angle opposite to larger side is larger, or you can call it greater. Okay? Okay. What does that show? That shows that if I have a triangle, let's say I have a triangle like this. Okay, let us say let me draw it differently a little bit because it doesn't show the one that I wanted to reveal. Let's do it this way a little bit. So let's call it A, let us call it B, and let us call it C. So if two sides of a triangle are equal, so let us say AB, as I said, AB and AC are unequal. So we will say that then we have to show what is given? given is AC is greater than AB. Therefore, to show angle B is greater than angle C. Okay, let's use our usual procedure. Okay, means this is an established method. From AC, let us take something equivalent to AB. That means I will draw this line, okay, and call this one D. So that means here AB equal to AB. Okay, that means this side is equal to this side. As soon as I do that, therefore, this is by construction. This is by construction. Okay. So I have now, let me again write down the this thing, notations as I call them, 4, 5 and 6. This is a notation of the angle. Okay, then if you see this triangle, in this triangle, okay, angle 2 is equal to angle 4 plus angle 5. Okay, this is because angle 2 is an external angle, angle 2 triangle DBC. Okay, this is an external angle to DBC. So therefore, I can write angle 2 is greater than angle 4. Accepted? This is accepted because of the fact that angle 2 is greater than angle 4, because I have taken out angle 5 from here. These were the equal. So if I take out angle 5 from here, then the 2 is greater than angle 4. Okay, this is done. Okay, now angle 2 is equal to angle 6, because I have taken by construction. Angle 2 is equal to angle 6. Okay, therefore I can write, I can go from here, I will go to this side here, okay, because there is more space. Angle 2 is greater than angle 6, because angle 4, because angle 4 equal to angle 6. Okay, now because 2 is equal to angle 6, this is 2 and 6 they are equal, now 4 equal to 6. This is to be seen here. Okay, now so we are starting, angle 6 is greater than angle 4. This is true. Okay, now if angle 6 is greater than angle 2, so if I add 6 plus angle 5, that will definitely be greater than angle 4. Similarity, if I take a simile, if 5 is greater than 3, then 5 plus 7 will be greater than 3, because I have added here, I have not changed anything. So this is similar to that, 5 plus 7, that will be 12, will be greater than 3. This is same to this, I am just adding one thing. So this greater than does not change. So this should be equal to, and angle 5 plus angle 6. Now if we go to the triangle, let us go to the triangle, another triangle. Now I will be considering the whole triangle. Now let us consider the triangle ABC. That means I am considering now the total triangle. In that triangle, 6 plus 5 is equal to angle B, and that is greater than angle 4, that is equal to angle C. Now, this is what we have to show. So that means this proves that the two sides of a triangle are unequal. So we have taken that two sides are unequal. So given AC is greater than AB, and then the angle opposite to the largest side. Angle opposite. What is the angle opposite to the largest side? AC's opposite is angle B, and AB's opposite is angle C. So B angle B is greater than. What did we do? We did a construction in which we made AD equal to AB, or this is like this, or this is same as saying AD equal to AB. Okay, we should have started because we constructed AD. Okay, so this is towards same. Then what we went to the exterior angle 2 is equal to angle 4 plus angle 5, because angle 2 is, angle 2 is write down in a better fashion. Angle 2 is an exterior angle to triangle DBC. So when we said angle 2 is greater than, angle 2 is equal to angle 4 and angle 5, that is we have done. So from here we have said angle 2 is greater than angle 4. Definitely angle 2 separately, taking individually, angle 2 is greater than angle 4. I could have also said angle 2 is greater than angle 5, but my interest is in angle 4, so I kept angle 4 and kept it here. Okay. Now angle 2 is equal to angle 6. Angle 2 is equal to angle 6, because, so let me write down angle 2 is equal to angle 6 by construction. Again, by construction, let me add this to make it complete. Angle 2 is greater than angle 6. So since angle 2 is greater than, so 6 would be greater than angle 4. From here I came to here, that is what it shows. I came all the way to here. So then what I did, angle 6 plus angle 5, I added up here. These two angles I added up, that should be greater than angle 4. So I came to angle total angle ABC. In ABC, this became angle B, and of course angle 4 is angle C, so that became greater than this, which proves this one. Okay, so this theorem, well, this is also 7.6. I should write down this is as a theorem. This is as a theorem. Okay, now we will go to theorem. Now this would be theorem 7.7, and it says in any triangle, the side opposite to larger angle is longer. So what do we have to prove? We have to prove that given larger angle is longer. So let us take a triangle. So I have taken a triangle ABC. Okay. So let us, okay, let me draw it a little bit longer so that it shows. And it is given that angle ABC, it is given that angle AC is greater than angle AB. This is given. In any triangle side opposite to the, it is given that angle B is greater than angle C. Larger angle is, and we have to prove, to prove AC opposite to this is AC is greater than AB. So what we have to prove, we'll go what is known as method of contradiction. The method of contradiction. What does it say? Say you assume certain things and you say which one is correct and which one is not falling into that. The method of contradiction. So what we'll do, if let us say if AC is given, AC, we have to prove AC is greater than AB, right? Okay, and AC is greater than AB, that means we have to prove this, and given is angle, let us write it down, angle 1, angle 2, angle 3. We have to prove angle 2 is greater than angle 3. We have to prove that, okay? Side, in any triangle, side opposite to larger angle is less. Side we have to prove this, and this is given. This is to, as he said, this is to be proven. Okay, and angle B means here angle 2 is greater than angle 3. Okay, what are the contradiction here? We will first say that there are three possibilities. So we will write down case 1. What is possible? AC is equal, AC is less than, AC is less than AB. Okay, this is one. Case 2, AC is equal to AB, and I will take case 3 here. Case 3 would be AC is greater than AB. Okay, let us take AC is greater than AB. That means AB is greater than. So that means AC is what? AC would be opposite to is AC is angle 2, and opposite to AB is greater, this is 3. That means we are saying angle 3 is greater than angle 2. Let me give this angle, and this is also, let me show this angle. Okay, this is not possible. This contradicts. The given. So this contradicts. So this is not possible. Okay, now what is AC equal to AB? Then angle 2 is equal to angle 3. This also contradicts. Okay, so this is also not possible. So case 1 not possible, case 2 is not possible. Let us come to case 3. So what is case 3? Okay, let me take out case 3 here, so I don't have to erase that. Case 3, I have said AC is equal to AB. That is angle AC is, that is angle 2 is greater than angle 3. That is angle 2 is greater than angle 3. So this is only possible. So theorem 7.17 has been proven in totality. So we consider two cases, case 1, case 2 and case 3, and there is no other possibility. Either this should be smaller or equal or greater. Those are the three possibilities we have taken. I have taken this one here, so don't, this is the same repetition in order to utilization the space of the board. So I hope there is no problem on understanding this. So we will, so we are going to the next theorem, which is 7.8, and 7.8 says the sum of any two sides, any two sides of a triangle is greater than the third. Let us understand this theorem. What is trying to say? So let me start from this side a little bit. So you have a triangle here. This triangle is A, B, C, and let us say I'll try on this side. So AB plus BC is greater than AC. Okay? Or BC plus AC is greater than BC plus A greater than AB. Or we have gone to BC. BC is then we will go to AC plus AB. AB is greater than BC. So either of these three conditions, either of these three conditions are either of these three conditions are true. Okay? Agreed? So this is true. How do I prove this? To prove this, I will again need a little bit of space. So what I will do, I need a space on these directions. So I will erase this part of it only, and I will draw this triangle from here. And I will make this triangle a little bit shorter, so that I can go and do some construction here. So this is A, B and C. Reproduce AB to D. Reproduce AB to D so that AD equal to AC. So what did I do? In triangle ABC, the side AB is produced to D so that AD, which AD we must write first, AD is equal to AC. Okay, this is done? Okay, that means this is equal to this. So if I take triangle DAC, let us try like that, DAC, AD is equal to AC, and then let me start with the nomenclature. 1, 2, 3, 4, 5 and 6. Therefore, angle 2 is equal to angle 1. These are by construction. Okay, by construction. Okay, I have not written the total, but I have written by construction. Okay, now let us take, since angle 1 is angle 2 is equal to angle 1. Therefore, if I add something on right hand side, I say angle 2 and then I add angle 3 and angle 3, that must be greater than angle 1. So this is means if say 5 is equal to 5, then if I add only one side, that means 5 plus say let us say 6, it must be greater than 5. This is logic. So or Archimedes axioms. So this, if you add something on this side, this will be greater than the 5. Okay. Now if I now go from there, I go to this. Okay. So angle 2 plus angle, then I go to triangle. Go to the triangle. I should not jump the cut. So I will take angle, total angle D, BC, DBC. What I will have, then I can say that angle 2 plus 3, angle 2 plus angle 3 is greater than angle 1. Angle 2 plus angle 3, that is angle C, is greater than angle D. Is greater to, equal to, greater than angle D. So I can say and write here that AD or BD is greater than from here, therefore BD is greater than BC. Okay, in this triangle, the total triangle, BD is greater than BC. Okay, now what is BD? BD is equal to, what is BD? BD is AB, this is AB plus AD. AD, that is greater than BC. Now what is AD? AD is nothing but, as is given, AD equal to AC. Therefore AB plus AC is greater than BC. So this is proven. So similarly, you can take another any two combinations and prove this thing. In that case, you have to extend, maybe you have to extend AC and then go a similar way. So this can be proven. So this is proven. Okay, this is proven, and we will go to the next theorem. We start with now exercise 7.4. So it will be exercise 7.4, and the first question is that show that in a right angle triangle, so that in a right angle triangle, so this side is right angle, this side is right angle triangle, the hypotenuse is the longest side. The hypotenuse is the longest side. Okay, so let us first draw a right angle triangle. Okay, so this will be your right angle triangle, and right angle at C. Let's say this is A, B, C, and this is 90 degree. Okay, so let us see in this triangle, angle A plus angle B plus angle C would be 180 degree, because this is the sum of interior angles of a triangle. Okay, now C is 90, so that means A plus B, angle A plus 90 is equal to 180, or angle A plus B is equal to 90. So that means, therefore, and this is equal to angle C. So angle C is greater than angle A and angle C is greater than angle B. Okay, this you can easily draw from this statement. So what happens if angle C is greater than angle, means what? Opposite to angle C is AB. AB is opposite to angle C. Therefore, and angle and BC is opposite to angle B. So AB is hypotenuse. Okay, here this is hypotenuse. Okay, so that means opposite to B. So AB is greater than BC. This is done. So hypotenuse is greater than BC. Next, angle B is sorry, I have written here equal to. So this should be greater. Okay, so angle C, since angle C is greater, again this is remains there, and so here I will write angle B should be opposite to what, therefore AC is opposite to angle B. Therefore AB is greater than AC. So AC, so AB, the hypotenuse is greater than, oh, I don't have to, once I use that sign, I don't have to write than, so is greater than AB as well as greater than AC. Okay, so this question, this is question number 1. Okay, so this question is here over. The essence of this, the logic is this, that you show angle B plus angle A is equal to 90. So since their summation is equal to 90, that is equal to C. So C would be greater than A as well as C would be greater than B. And so C is opposite, AB is opposite to C. So you take individually, first you take opposite to this thing. BC is opposite to B. No, BC is opposite to angle A. Therefore, AB is opposite to angle side BC. AB is opposite to side BC. Similarly, you take AC is opposite to angle B. Okay, so in that case AB is greater than this thing. This, there was a mistake. BC was opposite to angle A. So make that changes. Okay, sometimes you say something and you write something. You have to be a little bit careful about it. Okay, we go to question number 2, and there's a figure given. It says side AB and AC. So I will only write A here. So this is triangle are extended to P and Q respectively. P and Q respectively. So be careful about first one will be Q. So AB will be extended to P. So I will draw a line here in order to now define B and C. So PB is extended, AB is extended to P, and AC is extended to Q, respectively is given. So it says angle PBC is less than, now this is less than, not greater than, it says is angle QCB. This is given. This is given. Okay. To show AC is greater than AB. Okay. Now let us again go through the same process. I will start at 1, 2, 3, 4 and 5. Okay. Now if I write these two, angle, this would be angle 1 is an external angle, so this should be equal to these two. Let us say angle 1 is equal to angle 3 plus angle 4. Okay, and angle 5, so and show angle 5 is again external angle to the same triangle, is equal to angle 2 plus angle 3. Okay. Now let us subtract these two, 1 and 2. Let us subtract. So I will erase that, otherwise I won't be able to write that. Subtract 2 from 1. So I will have angle 1 minus angle 5 is equal to 3 plus 4 minus 2 minus plus 3. Okay, now if you, what is given this and this are less, so this and this one is less. Which one, this and this? What is PBC? PBC, that's angle 1, is less than QCB, is less than 5. So that means 5 is less than 1. So this side it will be positive. What is about this side? What is 3 and okay, let us say 4 and 5. 3 plus angle 4 minus angle 2 minus angle 3. This 3 and this 3 gets cancelled, so it becomes 4 minus angle 2. Okay, 4 minus angle 2. That means here this has to be positive. That means angle 4 must be greater than angle 2. Is this okay with you? This has also to be positive. So in order for it to be positive, then angle 4 must be greater than angle 2. If I am having problem there, negative, because I did not, because this is given, 5 is greater, so this is negative. So here, in order to have this, I have to have, instead of that, I have to have 2, angle 2 is greater than angle 4. Okay, the given is other. If it was other one, I could have done the same way. So angle 2 is what? This is, so AC, so I have to write AC is greater than AB. Okay, AC is greater than AB. So this is proven. So the point is here, you take advantage of the property of the external angles of a triangle. So this is the triangle. So I have taken the external angle properties. So that's why I have said angle 1 is equal to angle 3 plus angle 4. So and angle 5, again external angle, is equal to angle 2 plus angle 3. What I have done is this subtraction. This is important. If you forget to do that, no addition, this is subtraction. So 1 minus 5 is equal to 3 plus 4 minus 2 minus 3. So again, if you expand this one further, then you can see that this 3 and this 3 cancel and it becomes angle 4 minus angle 2. These notations are important because if you try to write angle A, B, C and angle A, C, B and all that, it will take enormous amount of time. So now you go to given. Given here, which is the one I should have checked before, that angle 1 is less than angle 5. Angle 1 less than angle 5 means this is negative, and similarly in order to get this one negative, I have to make this one is to make negative also, I have to make 2 is greater than 4. Okay, the error that I have gone through initially, you please take care of that, and this is proven, this is equal to this one. Okay, now we're now going to start on question number 3, and this is a figure. Again, it's a AB, and this is another line. Okay, now they are joined together. So this is A starts from the bottom and B, and similarly here C starts from this and this goes here. So AD is joined, BC is joined, okay. I like to draw these figures in your presence to show the importance, and this is intersects at O. It says, now given, what is given? This side is given, our given side. We always write given on this side. So given angle B is greater than, no, less than, be careful, less than angle A. This is 1, and angle C is less than angle D. Otherwise you will get into this kind of a problem. So show that. So come here. So that AD is less than BC. Okay, how do we do that? Let's see here in this triangle. Okay, now if I have to prove, it is given angle B, this is angle B, is less than angle A. Okay, so, or I can write angle A is greater than angle B. So angle A is greater than angle B, that means BO, A's opposite is BO or OB. Let me write OB. OB would be greater than, OB will be greater than, even though it is not showing, but OA. Because angle A, opposite to angle A is OB, opposite to angle B is AO. Okay, done? Okay. Similarly, it is given this angle, angle C is greater than, is less than, that means angle D is greater than angle C. I hope there is no confusion on this. All I have done, angle D is greater than. What is angle D? Angle D is this thing. So, this is greater than, this is opposite sides of the angles. Okay. So if we see angle D is greater than angle C, angle D means OC is greater than angle C, greater than OD. OD again, side opposite to greater angles is same thing. Opposite sides opposite of the angles. These and these statements are both same. Now you add OB plus OC. OC is greater than OA plus OD. That takes care of it. OB and OC is equal to BC. BC is greater than OA plus OD. OA plus OD, that is AD. This is what it shows. If I write on this way, I can write AD is less than BC. So that is given. These two statements are same. Okay? Is there anything? Nothing? You take two different triangles. You start with this triangle because it is given. There is no other problem. Then you also start with this triangle and you take advantage of the inequalities in angles. So sides opposite to the greater angle is also larger. So angle B is greater, A is greater than angle B. Opposite to is OB, and that is greater than OA, or this thing same. Go to this triangle, their angle is given, angle D is greater than angle C. These are given, so you do it. Only thing here, you add 1 and 2. What is those 1 and 2? So this is 1. Let me complete, and 2. So this is add 1 and 2. Okay, so this is what you get, and this is all done. So because, okay, let me put down another line that you will be complete. OB plus OC, OB plus OC is equal to BC, and OA plus OD is equal to AD. So that completes it in all the way. Nobody should have any difficulty in understanding it.